The Positive Feedback Loop of Bromus tectorum, Wildfires, and Climate Change by Risa Rushton. Here are some of the main points of this presentation. Bromus tectorum's home range is expanding because of climate change. Bromus tectorum is an invasive species that increases the frequency of wildfires. An increase in wildfire frequency assists with the global temperature increase. To the right of the screen, you can see a picture of a wildfire burning in a once farmland that is now taken over by Bromus tectorum. You can see the occasional bunch grasses within the screen, but most of the land is Bromus tectorum, which results in these fast-moving, high-intensity fires. What is Bromus tectorum, otherwise known as cheatgrass? Cheatgrass is an invasive annual grass found from coast to coast across the United States. Cheatgrass has become an ever-increasing problem for land managers in the United States. This is because of the plant's phenology, or different structures and functions of the plant. Cheatgrass is an annual grass which allows it to evolve quickly for changing climate. Cheatgrass also grows and thrives during the rainy season and is able to cure as soon as soil moistures are not enough to support the plant. Cheatgrass also thrives off of disturbances such as wildfire. These disturbances open up the landscape and make different resources available. Resources such as sunlight and nutrients. This allows for cheatgrass to establish before other native perennial grasses can. With the change in global temperature, there is an expectation that cheatgrass will continue to spread like wildfire. A study done in Utah tested this hypothesis. They found that the expected increase in cheatgrass may not increase as much as they originally thought. Cheatgrass does thrive off of dry and hot temperatures during the summers, but without enough water in the spring, cheatgrass cannot grow as much as needed to produce seeds. This lack of water could halt the spread of cheatgrass. So if scientists are correct and dry places get drier and wet places get wetter, the dry places may not be habitable for cheatgrass. Now we will explore the relationship between Bromus tectorum and wildfire. Bromus tectorum increases wildfire frequency, and it doesn't take much to increase this. Bromus tectorum is a fine fuel which cures in early July. This increases the biomass on the ground and creates a continuous fuel bed for wildfires to burn. It has also been found that there's a correlation between human-caused fires and cheatgrass. This makes sense because humans tend to spread invasive species. When you work on a wildland fire module, there is usually a requirement that after you drive around in places with invasive species, you must go through a weed wash before returning home. However, this is not consistent with the general public. Often, there are UTVs, ATVs, and other off-roading vehicles that are driven around in these invasive species, and then they are taken to other places where they can spread the seeds. This increased activity not only spreads the invasive species, but allows for more human-caused fires to happen, whatever that may stem from. This increase in fire frequency also results in a change in ecosystems. These fires are occurring more frequently than in historical values. This has become detrimental to ecosystems. As an example, to the left you can see a sagebrush ecosystem with a large cheatgrass component. Sagebrush are supposed to burn every 35 to 200 years. However, with the continuous fine fuel of cheatgrass on the ground, they now burn every 0 to 35 years, and often between 0 and 10 years. This is not enough time for for sagebrush to recover from these fires. This results in a loss of flora and fauna. Not only the sagebrush, but sage-grouse as well are affected by the increase in fire frequency. And we still don't know the full effects of the increased fire frequency on ecosystems. But how does climate play into all this? Warmer climate results in rainy winters, which increases the soil moisture for Bromus tectorum to grow. Warmer climate also results in longer growing seasons, or the gap between snowpack on the ground and hot summer days when Bromus tectorum cures. These two combined result in an increased biomass of surface fuels, or dead Bromus tectorum. There's also a correlation to longer wildfire seasons. Wildfire seasons are becoming longer and hotter with very severe and intense wildfires. To the right, you can see a very intense wildfire that is creating its own weather. As a result, this also leads to more extreme storms, as seen with other climate impacts. And now circling back around and connecting all the dots. Bowman et al. Said in 2014, relationships and feedbacks between climate, fire, and vegetation need to be evaluated as drivers of future fire activity. The picture on the screen shows the relationship between climate, vegetation, and fire. As shown by the thick black arrows, climate has a very large effect on both vegetation and fire. Vegetation and fire have moderate effects on each other and smaller effects on the climate. But these three are still very interconnected and affect each other. The picture also shows how much this triangle affects human and atmospheric CO2 conditions.